I'm Katie Cassetta, Associate Director of Aspen Ideas Climate and the Aspen Ideas Festival, the Institute's flagship event in Aspen in June. This session will run a little differently than other breakouts this week. You'll hear 3 short talks in a row with experts working at the cutting edge of climate tech. First, we'll hear from Jamie Beard, who's from Project Innerspace, a nonprofit using artificial intelligence to map the Earth's potential for geothermal development. Then David Bierman from Antora Energy shares how thermal batteries can store renewable energy when the sun isn't shining. And we'll finish with Juliet Rothenberg from Google's Climate AI team on how the tech giant is using AI to supercharge solutions across a range of issues. And just an important footnote, Jackie Sebens from Helion Energy, which is a nuclear fusion company, was supposed to join us, but picked up a toddler cold, unfortunately, and couldn't come. You may have seen the headlines from December about a lab in California that produced a nuclear fusion reaction for the first time that released more energy than it used. And Helion Energy has made the bullish statement that they plan to have a commercial nuclear fusion facility operational by 2028. Many are skeptical of this likelihood. Maybe some of you in the room are skeptical of this. And we were eager to have Jackie make her case in front of you, but the kindergarten sniffles have prevailed. There won't be a Q&A after each speaker, but in Jackie's absence, we will have a little bit of extra time at the end. So please do approach the speakers at the end and ask questions of them if you'd like. Thank you so much for coming and enjoy.
Thank you for inviting me here. So I'm going to talk about geothermal. My name is Jamie Beard, and I run a nonprofit called Project Innerspace. And before we dive into geothermal and AI, it might make sense to just talk about why you should care about geothermal. And, and as I've kind of circulated around the conference, I think this is probably really important to do. Just out of show of hands, how many feel like you know what's going on in geothermal right now? Meh, so that's like 3. All right, so love that. Okay, so let's start from the basics. Geothermal, what are we talking about? Where is the opportunity? Why is it important? Awesome. Okay, so we're here for climate. Climate's a thing. There's a lot of hand wringing and there's a lot of doomerism, right? Especially when you walk out of the optimism of this conference and you talk with the general public. Geothermal is a really shining spot when it comes to thinking about the future of energy, how we can go big, how we can scale fast. We can kind of move past the sad polar bear footage and onto something that's really cool, right? And really hopeful, and that's geothermal. So backing it up, what is geothermal and where does it come from? The core of the Earth is the temperature of the surface of the sun. And all of that heat emanates. Now, we don't burn our feet when we stand on the ground barefoot, because the crust is an incredible insulator, but all of that 6,000 degrees Celsius heat emanates and is stored in the earth. That's geothermal energy. It can be used for a lot of things. It's ubiquitous, it's everywhere, it's near limitless, and it's really freaking hot. The further you go, the hotter it gets. That's geothermal. It's a massive, scalable, clean energy opportunity, and here's the key. It's everywhere. It's not just in Iceland. It's everywhere. So most people, when they think about geothermal, they think of this, right? So it's like, oh yeah, hot springs, yeah, that sounds cool, but not relevant to climate. Wrong, right? So this is the misconception for geothermal. In the past, we have developed geothermal in places that it's right there close to the surface, right? Sitting next to volcanoes, sitting next to hot springs. Those are surface manifestations of geothermal. That's where it's easy to get to and we use it there. So if you think back to the early days of the oil and gas industry, that's how we did oil and gas. It was sitting on the ground in puddles in Texas, and we decided we could pick it up and burn it. Then we started drilling for it, and now we're doing offshore, super deep water oil and gas. Geothermal right now is sitting on the surface, and we're doing it in places where it's there. But what about all the other places in the world where we need clean energy and there's a ton of demand, but it's a little bit deeper? That's the opportunity, and that's what we're talking about. Really, really big opportunity. Now, how do we do it, right? So we've got Iceland. It's sitting on the ground. It's really easy to drill. You can drill it blind. You can dumb drill it because it's literally right below the surface, right? And so that's why we have clean electricity, geothermal electricity in Iceland. We also have geothermal heat. All of Iceland's heat is provided by geothermal energy, right? So what does it take to do it in other places in the world where it's not laying on the ground? Well, for one, this is not a moonshot, and this is also what is really new about geothermal. So over the past 15 years, there was this thing called the shale boom in oil and gas. And essentially what that was an enormous amount of technological development that went into new drilling techniques. One that I love is directional drilling, right? So they figured out how to turn and steer drill bits to get right where they wanted to go underground for the purpose of producing natural gas. But if you take all of those technological developments that have already happened in oil and gas and you just plop them down into geothermal, we now have the opportunity for an immediate 50% cost reduction in drilling costs for geothermal and capabilities to do it in many, many more places in the world, right? So geothermal everywhere. Geothermal is everywhere, and we need to figure out how to get it. Now here's the catch, and this is one of those, this is the ringer that gets me when I'm talking in front of climate and environmentally minded people. It's the oil and gas angle, right? So in geothermal, and what you're looking at now in this video is, these are startup pilots. So you've probably heard of startup companies like Fervo Energy, if you've been paying attention, Sage Geosystems. There are a lot of startups in the field right now working on geothermal. Many of them are oil and gas veterans that have started geothermal companies and are doing really awesome technology transfer into the space. And there's been this renaissance of innovation, cost reduction, et cetera. And this has all happened in the last 12, 18, 24 months. So this is all brand new and really cool. But where we get hung up is the oil and gas piece, because what we have to do to scale geothermal really quickly is bring together polarized entities like oil and gas and environmental groups. And that's where we get hung up on ourselves, right? Because and I am one of these people, an environmentalist who I dedicated my life at 9 years old watching Exxon Valdez to making sure oil and gas burned. Like that was my life goal as a child. And so when you run into feelings like that, it gets really hard to build collaborations and alliances where you find a place that you can agree, right? But this is also the amazing opportunity for geothermal to bring all hands on deck, right? So what happens if we did that? So we figured out a way, oil and gas, environmentalists, climate groups, agree on a way forward, go for it. What could we achieve in terms of scale? And this is probably gonna be a little bit surprising because it's absolutely massive. So if we were to drill the same exact number of geothermal wells as we currently drill for oil and gas globally. So right now, the oil and gas industry, at its current speed and scale, drills 70,000 wells per year to produce oil and gas for us. Now, if we were to do that between 2030 and 2050 for geothermal, so let's just give it a couple of years, start in 2030, drill 70,000 wells a year between 2030 and 2050. By 2050, we will have met 77% of 2050 electricity demand. So future electricity demand, which is much, much bigger than today, and more than 100% of global heat demand. And remember, I'm not talking about heating buildings. Yes, I am, but the bigger opportunity is industrial heat. And remember, industrial heat, manufacturing processes, these are really hard to decarbonize sectors. And geothermal is really good at it. So, let it sink in for a moment. 77% electricity, 100% heat. Where did this come from? And I imagine in most conversations that I have, people are really surprised at these numbers. And what this is the power of all hands on deck. Geothermal has languished under 1% in this other category in penetration models for 2050. And it's that way because the presumptions are built on the fact that the geothermal industry is tiny. And it has a huge way to go, right? I mean, we're almost building it from scratch right now. But if we get the oil and gas industry excited and borrow their speed and scale, so current, already trained workforce, they know how to drill, characterize, and produce subsurface energy. They're just doing it for oil and gas. Flip that, oil and gas to heat, right? So you've got the workforce, you've got the technologies, you've got the global footprint and scale. And all of a sudden you have massive opportunity. All right, So where's the catch? And there are some blockers. And the blockers are where our nonprofit is focused at Project Interspace, trying to figure out how we can remove the major barriers that are standing in the way of massive growth, global growth of geothermal, and how we do it really fast. And the oil and gas, the polarization issue is one, and we're spending a lot of time on that, trying to convene entities to talk about geothermal. And I mentioned yesterday in a panel, our most recent convening was the Environmental Defense Fund at Halliburton's headquarters in Houston. And that had never happened before. And the topic was, how do we build geothermal together? And it was a nervous opportunity, right? And it was tensioned at first. And then, EDF got comfortable enough to take unfiltered and unmoderated questions from an audience of 250 oil and gas executives by the end. And it was really awesome, and it was really candid, and it was really honest. So we're focused on those types of convenings, but there's also other blockers and barriers that we need to focus on. One of them is, let's say we don't see geothermal on the surface in a place in the world. So there's no volcanoes, there's no hot springs, there's no geysers. It's just, let's just say it's here. So we're in Miami, and we want to do geothermal. We don't have any idea what the subsurface looks like underneath us because there's not oil and gas drilling. We don't have wells, we don't have data. How do we know where in the world we should do geothermal first if we don't have it laying on the ground and we know it's really shallow, right? And so the question is, how do we map that, and how do we use AI to map that? And so that's how we wrap AI into geothermal. So Project Interspace built a partnership with Google, and so sorry, my animation screwed up. This is a growing tree. We're breaking through the barriers. All right, so GeoMap. We built a partnership with Google. We're building Google Earth for geothermal. GeoMap was launched, the first continent was launched at COP28. We launched Africa. We're launching continent by continent. We are focused right away and first off on emerging economies where geothermal as a base load energy source, which is very important, can slip in and take the place of new coal capacity, right? So we are focused on places in the world that are experiencing energy poverty and a lot of growth, and that will have the 2050 population centers that are going to contain the demand centers. And we're going after those first. So GeoMap, we launched Africa. These are all the subsurface data layers that go into GeoMap. We use algorithms and machine learning to bring them all together in a weighted analysis. Here's Nigeria, is a little zoom in to what the surface looks like for Nigeria as a case study. This is where Google's data comes in. So we also use machine learning and AI to estimate down to the building level what heating, cooling, and electricity demand looks like in places where that data is not available currently, right? So if you look, this is a neighborhood in Lagos, and you can see the darker the red, the more energy or heating or cooling that building uses. So GeoMap is the freely accessible geothermal prospecting map of the world, and it will roll out continent by continent over the next 2 years, with India and the United States coming in the next quarter. All right, another blocker. Post GeoMap, Interspace, realized that the startups, so the furrows of the world that are charging into the field, were having a really hard time getting funding, and this is a unique problem for first of a kinds in climate. I'm sure you've heard the first of a kind problem a lot. Geothermal, though, has a really special first of a kind problem because it has multiple layers of risk that are all really hard to deal with. So you've got the subsurface risk, which is already a pretty hard one to deal with. And then you've got on top of that novelty, first of a kind, never done before in this region, and there's technology risk, because we're transferring oil and gas technologies that have never been utilized in the geothermal context into geothermal. So you've got 5 layers of risk and nobody wants to fund it, right? So Project Interspace is working to build a new asset class that will help leverage the advanced market commitments of technology companies to securitize those commitments to where we can actually get some pilots funded over the next couple of years that will be highly catalytic. And we, as the nonprofit, will actually fund 2 pilots both of them likely to be in India this coming year. One will be a cooling pilot. And this is it's complicated to talk about geothermal as cooling. Ask me after if you would like to, but just to say, if you've ever been into a cave and you've realized it's cold down there, it's 55 degrees Fahrenheit. That's everywhere, all over the world. And that's free cooling. So we call that geothermal too, because it's energy that's under the ground. Even though it's cold, the deeper you go, the hotter it goes. But think about that. Free cooling in places that are under the threat of a wet bulb event. That's free cooling. We don't have to electrify that, right? So we're gonna do a cooling pilot and also an industrial decarbonization pilot in India this coming year. All right, so to wrap this up, I just wanted to say, since there were only three and a half people in this room that knew anything about geothermal at the beginning, if you find this at all exciting and a cool space, and it is, it's frontier land and it's blue sky, meaning we need brains. I haven't been in geothermal more than 8 years. And here I am talking about it, right? And this is a massive opportunity for new people to engage in a space that is very quickly growing and that has massive potential. And I don't just mean engineers and geologists and stuff. Yes, we need them for sure. I mean lawyers and communications professionals and artists, right? The types of folks that have not engaged in the space right now, geothermal has a massive education problem. Educators, people that are interested in doing documentaries, writers, journalists. I mean, we need everybody. So if you're interested in the space, please come talk to me, and I can kind of introduce you into some folks in the space that are building and hiring, and we'd love to engage new folks. All right, that's it. Thank you very much. Thank you very much for listening. And next up, David.
My name is David Bierman. I'm one of the co-founders of Antora Energy, and I am super excited to be here to share with you about what we're building at Antora. It's a tool to rapidly decarbonize the industrial sector. When we started Antora Energy, we just opened up with a pretty simple question. What is the biggest positive impact we can have on climate change? And to answer the question, we just looked to what is the biggest driver of emissions globally, and it's the industrial sector. Over 30% of global emissions come out of the industrial sector. That's more than any other single category in the world. And that number has to go to zero if we're interested in maintaining a livable planet, and it has to happen as quickly as possible. But until now, fossil fuels are the only really viable option to run an industrial facility. It's the only option that gives you a cost-effective, reliable, always-on source of energy for some of the most energy-hungry facilities on the face of the earth. But we're truly at a turning point. Wind and solar electricity are now the cheapest sources of primary energy that humans have ever been in contact with. Some of the largest sectors of the economy, like the power grid and transportation, have been rapidly and fundamentally transformed because of this new source of primary energy. But industrials have really struggled to tap into this source of primary energy for one pretty straightforward reason. There hasn't been a cost-effective way to store intermittent renewable power at an industrial scale. But if you could, the prize is absolutely enormous. This is a map of the US Midwest and all the industrial facilities that 24 hours a day, 7 days a week, 365 days a year buy and burn fossil fuels to produce the energy they need to run their factories. And overlaid on this map is actually the wholesale price of power in the bottom 1/3 of hours in the year. So basically when the wind is blowing and when the sun is shining. And what you can see is the power in the regions where you're running these industrial facilities is cheaper than the wholesale cost of buying a fuel to burn to make steam or power for your facility. This is an unbelievable phenomenon. It means that if you could find a way to collect and store wholesale electricity, or electricity coming from wind and solar at these times, and find a way to then dispense that every hour of the year for these industrial facilities, you have an opportunity today in the United States to undercut the cost of natural gas at major industrial facilities. And that's exactly what Antora is focused on. We're developing thermal battery modules to link intermittent renewable power to major industrial facilities across the United States and across the world. These are long-duration thermal energy storage systems that give you the reliability and the cost effectiveness that are needed at that industrial scale. So how does it work? It's remarkably simple. We take electricity from the sources of wind and solar when they're in excess, and we use it to just resistively heat this heater coil. This is exactly what happens in your toaster oven in your kitchen. No different. We heat this element, which is made of carbon, to extremely high temperatures, and then it radiates that heat to large carbon blocks, raising their temperature to above 2,000 degrees Celsius. That is hotter than almost any industrial process runs, and it's hotter than even the so-called hard-to-decarbonize sectors like steel and cement and chemicals. Why carbon? Carbon is one of the most interesting materials I've personally ever encountered. It is actually one of the most common industrial materials that you've never probably thought much about. And that's because it's an intermediary in a lot of major industrial processes like aluminum smelting or steel production. Carbon is consumed just behind aluminum in the most common industrial material. So that's a very good place to start. It's incredibly cheap. It's produced at incredible scales on every continent on Earth except for Antarctica. That is like, these are necessary attributes to achieve the scale and the speed that is required to meet our climate goals. Also, it's a remarkable place to store energy in a very simple and very safe form factor. You can get an enormous amount of thermal energy in a carbon block, in a very small carbon block. So with ultra low cost electricity coming from wind and solar and a long duration, simple, safe thermal battery, we open up a decarbonization pathway for industrial heat immediately. And not just one that is significantly lower cost than some of the other common decarbonization pathways for industrial heat like CCS and hydrogen and RNG, but one that actually could directly compete today with natural gas. And that's not all we're up to. We are also developing a breakthrough thermophotovoltaic power generation device, which is a system that can absorb the radiant energy that naturally emanates from these very hot carbon blocks and directly convert that back into electricity. So in addition to delivering cost-effective, reliable heat, we can also make firm, clean power. And that gives us the first renewably powered combined heat and power system for an industrial site, covering the two major feedstocks that go into an industrial facility: high-grade heat and power, both on demand. So our thermal batteries are modular, they're shippable, they're factory made here in the United States. They have low-cost, earth-abundant components with no complex supply chain constraints. And they are going to be manufactured. They're going to be manufactured at incredible scales over the next few years, going to any continent, any industrial sector that needs high-grade heat and power, any scale, small or large. Last year, we built our first full-scale system and deployed it at an industrial site, delivering 24/7 heat and power. This year, our focus is on ramping up our production facility in San Jose, California, where you'll have thermal battery modules rolling off the lines, getting on trucks, and shipping out to customer sites in the US Midwest. So every time a new primary energy source has emerged in the world, it has created an immediate and fundamental change in both the energy and industrial systems that we operate. Think about coal 200 years ago, or oil 100 years ago, natural gas 20 years ago. Today, renewable electricity and the advent of low-cost, abundant, clean power will drive the same kind of transformation and it can happen in the industrial sector in, again, a way that can save enormous amounts of money, but more importantly, cut emissions in the industrial sector immediately. And this vision that we have is shared by some of the major financial players in this space. We're supported by Decarbonization Partners, which is a joint venture between BlackRock and Temasek, two of the largest money managers in the world, as well as Breakthrough Energy Ventures and Lower Carbon Capital, leading voices in the energy transition. Additionally, we've been super lucky to be supported by a number of public funding sources like Department of Energy, ARPA-E, the NSF and California Energy Commission, and many others. So I'll just leave you with one takeaway. We have the tools we need to decarbonize industry. Much of it is not hard to abate, like you hear. By pairing low-cost renewable electricity to industrial sites using thermal battery modules, we have a simple formula that we're going to roll out to drive deep decarbonization over the next years and decades. Thanks.
Hi everyone, my name is Juliette Rothenberg and it's my job at Google to use AI to tackle climate change. That means I spend my days with teams of researchers asking questions like, how can we tackle over a third of aviation's warming impact without changing any hardware? And how can we predict climate disasters before they strike? Now, you might wonder, why is somebody from Google asking these questions? And that's fair because most people, when they think of Google, think of a search box on a web page, right? But actually, Google's mission at its core is to organize the world's information and make it universally accessible and useful. And I don't think I need to persuade any of you here today that some of the most important information that we can make useful is information about climate change, particularly how to mitigate and adapt to it. And couple that then with the breakthroughs in AI. And what I think is so exciting about AI, and the reason that I joined Google, is the pace of innovation. AI is changing so quickly, and it's deploying incredibly quickly across many, many, many different applications. And when we think about solutions that need quick innovation, quick pace of growth, and also quick deployment, climate change is very high on that list. So today, we're going to be talking through a few different applications across energy, transportation, and adaptation. And what I hope you'll see is that we absolutely need to decarbonize and shift over our infrastructure, as you've been hearing about already today. And we also need solutions that can be big and that can be deployed in years, not decades, across our entire economy. And so we'll be talking through some examples of what that looks like across different sectors. So let's start with energy. Here we go. So let's start with energy. And energy, of course, as you know, we need to move over to renewables as quickly as we can. Jamie was talking about geothermal, and we also have a number of renewable resources that are available today. But how can we bring more of those onto the grid quickly? That question gave rise to our solar API, which uses AI to characterize the solar potential of a rooftop and rapidly prototype what system design looks like, as well as cost savings to help consumers go solar. You all know residential solar is on a very fast cost curve, and what we've seen is that when solar installers use the solar API to help customers understand the cost savings of going solar, they can deploy more systems. More customers want to adopt solar, because you probably know, if many of you have solar, you probably also thought about the economics, right? Even people in this room who are extremely motivated by climate change need to care about the economics too. And if we can help make these decisions and put these informations at people's fingertips, we can help people move towards climate-friendly solutions. The Solar API has data available for over 470 million buildings worldwide. We're expanding that out rapidly to many regions of the world that have increasing solar targets that want to move to renewables quickly, as we've seen here in the US and elsewhere. Now, how many of you have heard of renewables interconnection queues with grids? Anybody? You all know, right? There's a lot of renewables. People want to integrate renewables into the grid. But grid operators simultaneously are saying, hey, I need to keep my grid reliable. And you probably appreciate that too. I know that I do. I like having a reliable grid. I think we all do. But grid operators have to run a lot of studies when they interconnect new renewables. They need to model out things like aging infrastructure, extreme weather patterns. All of this is very computationally intensive and takes a long time to run. So Tapestry, which is an Alphabet company, is working to build AI-based tools to help grid operators make decisions more safely and quickly using AI. Chile's national systems operator has a really ambitious target. This actually wasn't something that I was previously familiar with. They're targeting 100% renewables by 2030. So talk about big solutions very quickly. Tapestry has been working with them to help them run their grid simulations. And what we've seen is that they're able to run 30 times the number of simulations simultaneously. That helps them integrate more renewables confidently and safely into their grids. All right, now let's talk about methane. So methane, of course, affects the energy sector as well as other sectors. Everybody in this room probably knows it's a very potent greenhouse gas, one of the major contributors to climate change. And on a molecule per molecule basis, it's significantly more warming than CO2. Now, Google's been really excited to partner with EDF recently around our methane sat. I assume many of you have been following the launch lately. It's been very exciting. And methane sat is going to allow EDF to track methane emissions globally and use algorithms on Google Cloud to determine where there are methane leaks. Now at Google, we're taking this one step further and saying, all right, can we understand where the oil and gas infrastructure is around the globe, harkening back to that beautiful map of oil and gas infrastructure that Jamie showed you, but a little bit perhaps of a more realistic one of where the assets actually are, so that we can understand where are the potential sources of leaks. Historically, this has been really challenging because oil and gas infrastructure actually changes quite quickly. There are many, many wells being built and decommissioned over time. And Google has a long history of building maps, and so we're using satellite imagery together with AI to provide EDF with a comprehensive view of this. Now, speaking of maps, let's talk about transportation, another sector of the economy that we know we need to decarbonize, and we know we need to decarbonize quickly. Now, how many of you all like stop-and-go traffic? Nobody? Well, it turns out that the climate is with you. The climate doesn't like stop-and-go traffic either. Pollution at intersections is 29 times higher than on open roads, and about half of that comes from the actual stopping and going of a very large vehicle. It takes a lot of energy to get that moving again after it stops. So Project Greenlight is using AI and Google Maps driving trends to optimize traffic lights. And we're doing this to reduce stop-and-go traffic and reduce emissions while simultaneously also reducing frustration for drivers. So we've deployed this now in 12 cities on 4 continents, from cities like Hamburg, Germany, Seattle, Washington, to Bangalore, India, and Jakarta, Indonesia, very different driving environments. And what we're seeing is the potential to save up to 30% in stop-and-go traffic and up to 10% reduction in emissions at city intersections where this is deployed. Now let's talk about contrails. What I love about contrails is that it's so surprising as a large solution, but it really is a significant fraction of emissions. So those little white lines that you see behind planes are responsible for over 1/3 of aviation's warming impact. You may wonder, how does this occur? It's a common question. It was my first question when I heard about this. All cirrus clouds trap heat into the Earth's atmosphere, especially at night, and prevent it from releasing into space, which is ordinarily what would happen. And contrails create incrementally more cirrus clouds in the atmosphere. So you're getting more heat trapped. And of course, global warming is just the balance between inflows and outflows of heat into the Earth and back out. And so contrails are changing this balance, and it leads to over 1/3 of aviation's impact. Now, at Google, we heard that contrails could be seen via satellite imagery. And we thought, great, can we create AI models that can recognize where contrails will occur, combine that with large-scale weather data, combine that with large-scale flight data, and then predict where contrails will form? So we created these models. We partnered together with American Airlines as well as Breakthrough Energy, and worked to say, all right, how do these do in the real world? Can a commercial airline actually tackle over a third of their footprint using AI. And what we saw is that in over 70 flights with American Airlines, their pilots used our predictions to try to avoid contrails. And then we looked in satellite imagery and we said, all right, what happened? And contrails were reduced by 54%. And the most exciting thing about this is that all the pilots did was adjust their altitude a few thousand feet. Now, that you probably know, you've probably heard it on flights. We're adjusting our altitude to avoid some turbulence. Pilots do this every day. This is a really known thing how to do. And so when we talk to airline executives and we say, how long till this could scale up? How long till this could be a solution for you? And they say something like, 2 to 5 years. This can be years, not decades. And compare that with the other solutions in aviation that you all are probably familiar with, right? Electric planes, hydrogen planes, biofuels. We need to move to those infrastructure solutions too, right? We can't get away from infrastructure solutions. We have to do them as a society and as an economy. And if we can have solutions that we can tackle very readily and quickly sooner, we absolutely need to do those because the climate can't wait. We need solutions today too. So that's why we're really excited about contrails, is the potential to have that impact on the really near term. We're continuing to work with American Airlines as well as other airlines. We're also partnered with Eurocontrol Airspace in Europe, over one of the busiest airspaces in the world, to expand this out in other continents later this year. Now, one of the great things about Google overall is that we have this incredible channel to consumers, right, who are coming to Google for information about how to make decisions. And we know that people often want decisions about how to make more sustainable choices in their daily lives because so many people want to be a part of the climate solution. So our fuel-efficient routing product helps drivers take the most fuel-efficient route in cases where it's not already the fastest by giving them a choice of which route they want to take. That way they can make more informed decisions. This feature has been really popular in the US. We've rolled it out to Europe. We're rolling it out as well to many other countries around the world later this year. And we're seeing really strong uptake from people feeling like they have the power to make decisions and they can make those decisions today. Now, when we talk about today, right, we have a lot of solutions. We need to scale these today. The other thing, as you all know, that is here today, unfortunately, is climate change. And as we look at solutions to climate change, now that we've passed 1.5 degrees C, we believe it's really important to provide people and communities and governments with information to help them tackle the climate crisis that they're facing. So let's take floods. Floods are responsible for many, many, many deaths every year. They affect tens of millions of people worldwide. That rate is increasing significantly due to climate change. So Google has used AI since 2018 to build breakthrough hydrologic models that forecast floods up to 7 days in advance. What's exciting about this is that we know that early warning systems can significantly reduce mortality from climate crises. And so if we can give people information in advance of climate disasters, they and their communities can take action to protect themselves. So on our Flood Hub, we provide 7-day advance forecasts for over 80 countries covering over 460 million people worldwide, expanding that out again further this year to help people respond to floods and disasters in their communities. Now, as a native Californian, I personally have never experienced a flood. I can tell you, most native Californians have personal experience with wildfires. I, like many other Californians, am one of them. And this is a feature that is very popular with people who live in wildfire-prone areas. It's our wildfire boundary tracking in Google Maps. This feature uses AI coupled with satellite imagery to track wildfire boundaries in near real time and then updates every 15 minutes so that people have the information that they need in order to remain safe. We have this live now in many fire-prone regions, and we'll be expanding it out again later this year. Now, if anybody is a city in this audience, I imagine everybody in this audience is a city or at least a county resident. But if anybody actually works for a city, we also have tools that are specific for cities as well via our freely available Environmental Insights Explorer. So this tool helps cities and local governments understand their carbon footprint and then set goals so they can track these goals over time, as well as understand actions that they can take to both mitigate and adapt to climate change. I encourage you to check it out or also refer it to your cities. We have this data now available for over 40,000 cities, and we have over 1,000 cities who are using this tool to help with their sustainability strategies. I think based on the people that I've seen here at this conference, nobody needs to be convinced here probably that cities and local governments can be a big part of the solution to the climate crisis. So we've talked about a number of different solutions to climate change that AI can enable in the very near term across energy and transportation and adaptation. And the biggest piece that I hope that you take away from this is that, yes, we need infrastructure changes. Absolutely, we have to do that. And we also need to insist on nearer term big solutions today. We can't just wait for solutions that will take a longer time to scale, because we have breakthroughs today that we can work with, and AI can help. And of course, this is something that Google can't do alone, right? We actually have a partnership, as Jamie mentioned, with Project Innerspace, as well as many, many, many others across this space. And what I'd encourage is for people in this audience, as well as others, to develop and use and advocate for solutions like this so that we can have more near-term solutions for the climate crisis today. Thank you.